In today's session, what we will do is we will do a quick orientation. So I will introduce you all to the roadmap of the entire course. So I'll give you a high-level overview. I'm sure you all checked out the syllabus on, the web page. But here we're not going to go into that detailed breakdown. So I'll just give you a high-level orientation week-wise on what we will do on, starting each week, so we get a better idea of where we are at and what we are going to do next. And then I'll also introduce you to the format of every day's class and give you a few highlights of this course. So to start with my introduction, so this is always the difficult part. I'm Swati. Some of you must have already, known about me from the demos and everything. So I'm a computer science engineering graduate, and I've been a QA since the last 10 years, I must say, since 2004. I've always been a QA, and I'm CST and CSQA certified. I'm also into a little bit of automation testing, into Agile here and there, everywhere, basically. And I love doing what I do. I've been playing the role of a facilitator for about a year now, or in fact more than a year now, and we've had a lot of successful manual testing. We've had a lot of successful batches who have taken this class and, who have had really successful results, and I hope that you will all follow suit and enjoy the class and, get set for the future success that I know is coming. So this class does not have prerequisites, as you all know, so we have pretty much a good mix of both experienced and freshers and people who are not from a computer science background, and that is true of every batch. And some of you have already emailed me letting me know that you're a little nervous about not being able to not being from a computer science background and wondering if you'll be able to catch up or not. Rest assured, we try and keep this class as technical as possible. So I'm one of the people who believes in the concept that there is really no, there's really no concept that's too complicated that cannot be broken down into simple, constituent elements. So that's the way we are going to take this class. Quick check again. Is my voice okay, team? Okay. Thank you. So Surabhi, the best way to do this is, just log off and try to log back in, and see if that works. Again, Sandhya, can you please send the instructions to Surabhi one more time, please? Thank you. In this class, we don't take anything for granted. We start from the absolute beginning, assuming that we are all starting from zero, and by the end of this session, we all aim to become proficient in the software testing, manual testing fundamental concepts. Irrespective of what background you come from, this class is going to be, easy to get on with and all those things. So if you feel like, something is not working out, and if you feel like, a certain topic that is in your mind is not being taken in as part of the session, let us know. We'll see if we can, incorporate it or, pay special focus on it so that it will be most beneficial to you all. And the way I like to have these sessions is not really, in the sort of a monologue-based thing. So it's not going. So there is no restrictions on how often you can ask questions, and how many questions you can ask, and what level of proficient questions you can ask. So feel free to ask all your questions. This class should be in the style of a workshop, not necessarily like a webinar. So that's a point of reference that we always want to keep in mind as we go through these sessions. So let me quickly show you the high-level overview of all the topics that we are going to cover. Now, I like to break them down based on the weeks, and I feel like, that gives an overall perspective of what we are going to do in a certain week instead of, breaking it down into small individual topics. So in the week one, we'll try and understand the software development lifecycle models. Now, Software development lifecycle models are nothing but the way in which software gets built. See, there is no reason why two people or two companies or two entities have to build the software in the exact same way. And at the end of the day, software is a product, which means it starts at zero, goes through different stages, and at the end of it, you have a product, ready-made, fully functional, completely done product, or at least an intermediary level of result. So there are different stages. There's a standard process that is followed. Again, standard to a certain extent, of course. So the standard process that is followed by companies in order to build a software and the individual stages in it is called the software development lifecycle. We'll deal with all that going forward. So in week 1, we concentrate more on the software development lifecycle. Now, since we are testers, why is this important? The reason why it's important is because a good understanding of SDLC will not just prepare you to be, just a QA tester. So a good understanding of SDLC will, provide us the right foundation to be a well-rounded IT professional. This is especially important because testing is a reactive job, which means you will not be able to test anything until there's a product. And when you report the defects, there has to be somebody who will take over, fix those defects for you, and incorporate that into your final product. So there is a lot of back and forth communication happening here. So if we just learn about testing as an individual entity, we kind of miss out on all of that communication and who are the team members. So this kind of understanding is very, very elementary for us to move forward and understand software testing in a better way. So that is why we start at the very beginning, understand SDLC. There are different models. There's waterfall model, there's V model, and there's also the more, the more current or, the more newer model, which is agile. So the first 3 days, that's what we are going to do. On day 1, we work with SDLC. Day 2, we work with SDLC itself, but it's a different model, the V model. On day 3, we work with agile model. However, when we are working with SDLC, I know that this is not, this is not a core QA concept, but then we'll pay special focus and special emphasis on what QAs do and what is the role of QA when a certain development process is happening, what QAs do, and so we kind of like will pay special focus on the testing team per se. And week 2 we'll get into more hardcore QA topics like test documentation, test case writing, and week 3 we'll also go into change management, traceability. So pretty much all of these topics. And one more thing that I like to keep, open in the class is the order and the way in which we, deal with the topics. So in week 2, yes, we do have these topics, listed out like day 1, day 2, 3. I mean, of course, there's no day 4 and day 5, but approximately in week 2 we are going to cover all these topics. But again, if we feel like another topic is, makes a logical sense or something like that, we'll try to keep this schedule open. And in week 4, we do a lot of tools. So the tools that are included as part of this course are JIRA, which is an incident management tool. And then there is Bugzilla, which is a defect management tool. There's HPALM, but let me tell you upfront that this is just a recorded session. We do not have this tool for practice or anything. But with JIRA and Bugzilla, I provide you with a sample ID so you can get some practice as well. And then we will also take a look at qTest, which is a test management tool. So this is what we are going to cover in week 4, all of the tools and everything. Then starting week 5, we work with automation, and the tool that we'll use is HPUFT or Unified Functional Test. This used to be called QTP previously, but right now it's called Unified Functional Test. So we are going to take a look at UFT, but here the scope of understanding or learning QTP is limited because here we are going to try and understand the basics of automation. So for those of you who have never seen how an automation test works, or who've never tried hands-on on how automation functions really, it is hard to conceptualize and visualize the topic without practically seeing something. So that is the kind of gap this class tries to fill with the help of QTP, but it's not going to be a QTP tutorial or anything like that. And then we will also do in week 5, we also do some career guidance stuff. That is, we work on resumes, we work on interviews, mock interviews, we work on certification guide, and all of that. Just give me 1 second, team. So we also work on certifications and how to orient you towards certifications and all that. So all the job stuff is for the last week. So this is a detailed breakup of how we are going to, or what topics we are going to cover and in what order. And coming back to Padma's question, what is Selenium? Selenium is also an automation testing tool similar to HP QTP. All right. So this is the detailed topics, and then we also the way in which we'll conduct our daily classes, we break it down into 3 major sections. One is the vocabulary section. Now the vocabulary section, there's not a lot to it really. This is just we take 1 or 2 words, technical words, supposedly technical words, because I don't believe anything is that technical that it cannot be explained in terms of small things. So we take 1 or 2 technical words and we try and explain them. So this is pretty much what we do in the beginning of the session. We all know that every profession comes with its own set of words, own set of language, and the way jargon basically. And it can be pretty intimidating for a newcomer not understanding what we're talking about, even though it might be something that is especially really simple, but when you are not in that environment, it's hard to grasp meaning of few things. So we will take all that up in the vocabulary section. The next section is where we will deal with the main topic. So this is pretty much where we'll spend the majority of our time. And then there is also going to be a practical part to this session, which is pretty much your assignments. So here we will try and implement the concept that we learn via the main topic for a certain day. So if we are discussing the software development lifecycle, which is today, we'll try and think of an assignment that is fitting to the topic that we are learning. So I get to see, so there are 2 things to this assignment. One is you get to explore and see, how you feel about the topic. Get hands-on experience on it. And the second thing is for me to see how well the topic has been received and if there are any gaps in your understanding and things like that. However, sometimes I know that some of you are work full-time, so sometimes some of my participants, they prefer to do their assignments all at once over the weekend and send it to me, which is fine. So but then we do have an assignment part to the session. So every day session will be broken down into 3 parts. And in addition to all this, you all have 2 applications, 2 live projects to practice on. So starting week 2, usually in week 1, I keep all the assignments non-technical and I don't try to impose any restrictions around them. So I let you all feel free and experiment with the concept in any way you like. But starting next week, we will have more structured assignments and that is where we'll start working on the live projects and get really hands-on experience. And each class is recorded. I usually send out the recording and whatever documentation we create in the class. Say, for example, we're creating a test case document. I send out all the notes and I send the link to the recorded session to your individual email IDs. Is similarly the way, exactly the ones that you got your training invite to. And this will be sent out a few hours after the session. I wish I could send it immediately, but the thing is the GoToTraining needs to finalize the video and then I'll have to upload it. All of this process takes a lot of time. So Anywhere between 2 to 4 hours of time is what this process will take, but at the end of it you will have the recorded session, and the recorded videos you can access them lifetime. There is no limitation on it. So in addition to all this, you will have at the end of today's session, Vijay will send out all the bonus material, which includes ebooks and ISTQB preparation materials and all that. So that is a high level overview of today's class and this course, entire course in general. Every day we have a class for 2 hours, but I plan on taking an hour and a half to an hour 45 minutes and leave the rest for you all to interact and take any questions that you might have. So that's a little bit about the introduction. So before we proceed, are there any questions, team? Okay, so if there are no questions, we'll just I'll just start with today's topic. Oh, before that we do have a vocabulary, right? So let's get with the vocabulary. Is there any job assistance? So this is the kind of assistance that we provide. So if one of our students have an interview lined up, we sit with them, go over their resumes and everything and help them and answer some questions, give them some pointers. That sort of job assistance is there, but we neither have the capacity nor the right framework to be able to find jobs for you. So that part of job assistance is not available. So as this is covering only basics, is there any step 2 kind of course? Now this is important for, all of the topics that we cover in the class will set you to a level of anybody who has 3 to 5 years of experience in the manual testing field alone. But then if you have an aptitude or if you want to steer your career towards automation, that is definitely a specialization for which you will have to take a different course. But as far as manual testing is covered, this course is very complete. So do you have a course for automation? Vijay does have lots of courses, so you can actually check our website and you'll find all that information. If you would like, I'll give you the link at the very end of the session. Okay, so I'll just go on with the vocabulary part, but if there's anything else in the meantime, just feel free to communicate through the chat, or if you have anything to share with the class, just let me know and I'll unmute you and we can have a conversation. So I know this sounds lame, and I know this slide might look like it is too basic, but as I said, we don't want to make any assumptions. We don't want to start the course with any assumptions. So that is why we start with defining the very most basic of the definitions here. So when we are talking about what a software is, again, let's take an objective look at what the software basically is. Now a software is, to put it technically, a solution. Sorry about that. Now, why am I calling the software a solution? Now, let's say a few years before or a few years back in time, there probably was a need for people to convene remotely and conduct like a meeting or a training. Now, was this software, let's assume this kind of medium, this kind of mechanism was not available. So when something is not available, that means there is a gap. Not available, not availability, whatever. So there is no availability at that point of time. Now, how do we fix the situation? You will have to bring in a software, something like GoToTraining, that lets us convene. Now, what is GoToTraining? At its core, GoToTraining is nothing but a few software-based commands, or it's a software program, or it is code, or a few lines of code, or a few thousands of lines of code. But it is code, it is lines of code, it is an integration with a database, it is an integration with a server. So all of these are elements, but the GoToTraining software is nothing but a program, a code, at its core. But why does this code or this lines of code exist? It exists because this was a problem. Not having a remote or a virtual training medium was a problem, and GoToTraining, the software that is GoToTraining, is a solution. So anytime a software exists, whether it is in the form of a product or in the form of a service, it always is a solution to a certain problem. So that is something that it is very important for us to understand, because when we do understand this concept, software stops being one abstract object that is hard for us to understand. Because when we, especially as testers, when we are testing a software, we really don't worry about how the program is written or what lines of code is used. We are only worried about how well this solution fits or solves the problem. Are there any gaps? Is it failing in some areas? So since our focus is mainly on the solution and how robust the solution is, it is very important for us to understand what the problem is, and to basically grasp the concept that a software is lines of code at its core, but then for us it's a solution to a problem. Moving on. Project of course is definitely not an IT word. So let's say you wanted to paint your kitchen over the weekend. That becomes a project. Now project is anything that takes some time, effort, and of course expenditure. And this has a point of starting and a point of end. And when you have all of these inputs, you will definitely have an output. So a project is nothing but a piece of work that needs to be done. So in the context of IT, you can call the entire software development, that is, when the, some business owner comes with a problem. So the first step is a problem, and then you create a solution. So you can treat this entire, this entire process as an individual project. Or in IT, they break it down. So the whole entire process of development can be treated as a development individual project, or the QA can be treated as an individual project, or just deployment of the code can be treated individual project. So basically a project can be a big chunk of work or smaller, individual chunks of work. So any kind of work that needs to be done, and it takes some input, generates an output, and has few intermediary stages, that can be called a project. Next is domain. Now this is something that I wouldn't say scares everyone, but this is an area where everybody feels like we are falling short. Now we do have, we've seen a lot of participants in our class, and sometimes the focus on domain is a lot. Now first and foremost thing is we understand what domain is. Domain is nothing but a key business area. So what I mean by that is, when you look at sites like Walmart, Amazon, eBay, or any other shopping sites for that matter, you would have similar options. So you would have an option to browse through their, browse through their inventory. You will have an option to choose them. You will have an option to add them to the shopping cart, and then you can manipulate the shopping cart in any way you like, which means you can add items, remove items, all of that stuff, and you can check out, make different modes of payment, and all of that. And then when you look at sites like Bank of America, online banking sites, or your Chase Bank, or ICICI Bank. So when you look at any of these online banking sites, you would again have similar options. There will be an option to perform some transfers, view your statements, check your account transactions, all of those things. Now, why do you think, even if they are different applications, they all have similar functions? This is because they all belong to a key business area. So the assumption, the domain knowledge, a lot of emphasis is placed on domain knowledge, because it is the assumption that if I worked on, say, let's say Walmart.com page, then I'll be easily, adapt or bring that knowledge of having already tested e-commerce application into my Amazon testing as well. So a domain knowledge is preferred because with domain knowledge, with a certain, working on a certain domain, which actually, makes you knowledgeable about applications that belong to that key business area. Now the next question that usually comes to me at this point is, how important is domain knowledge? If I don't have any domain knowledge, how is that going to be a problem? Now, domain knowledge, it's always a skill that is good to have, but it's not something that is mandatory. The reason why that is true is because as testers, we are facing the application exactly the way an end user would face. So here's an example. So just because I have never, tested an online banking, I have not tested it. So when we're talking about testing experience in an online banking world, my experience is 0. But as user, have I used an online banking medium? I definitely have. And to actually get by, I don't have to be a domain expert. So if you were to check your, say credit card transactions or a debit card transactions, you really don't have to be a banking expert to do so. So when a user can get by without, carrying that domain knowledge expertise, the same is true of testers, because testers and users, there's not a lot of difference except in the mindset. Users, they use it. They are trying to, perform a particular task on the application. But when you're a tester, you're doing the same thing. You're trying to perform the task not because it's something that you want to do, but that it's because you want to make sure it's working fine. So here, as a user, your assumption is that a feature X on the application, say the transfer from of some funds from account A to account B. When you're a user, your mindset is that this will always work. So you're always in the yes framework. But when you are working as a tester, so when you are performing a transfer operation, there is definitely no change in the sequence of steps that you're going to follow as a regular user or as a tester. The only difference is in the mindset. So this is a yes or no situation or a maybe situation. So that is what sets us apart. So to be successful as a tester, domain knowledge is definitely not a prerequisite, and it definitely does not hold back from us being effective testers. And domain knowledge is a skill that you will, or it's a sort of it's a proficiency that you'll gain on job over a period of time. And if this is important, especially if you're trying to become a business analyst, or if that's the way in which you want to steer your career. But then nobody becomes a business analyst as a fresher. It's a role that is specific for subject matter experts. We'll go there in a little bit. But domain simply means key business area. The only significance that it holds as far as testers are concerned is that applications belonging to certain key business areas, they all possess similar features, which makes it easier for a tester to test it if they have worked on a similar application early on. Not having domain knowledge is definitely not an inhibiting factor to be successful as a tester. So I'll finish the rest of them and then we'll pause for questions. The next is technology. Now, sometimes, when you are in a professional conversation, you hear questions like, what technology is your project? What technology is your application? Now, there's really not a lot of, depth to this. All that this simply means is the technical details around which your software is built. Like, for example, if Java is used as a programming language, and if the database that's used is DB2 or SQL Server or any other, database that's being used, and they're using an Apache Tomcat or some sort of a web server. And if there are other technical details. So all of these technical details are the technology that your application is built around. The next thing is platform. Now this is slightly significant because, as and when we keep going further into our careers, you will be using a lot of tools like Bugzilla, JIRA and all of these. And when you read these tool specifications, they'll tell you the platforms on which these work. So without the knowledge of what platforms actually are, this kind of information might not be exactly as clear as it should be. So platform is an important thing to understand, and it's really simple. So platform is the target system configuration. Now you will see applications having different installations and different ways in which they behave for different different target systems. Say for example you have Windows, you have a Mac, or you have an with the with the coming of mobile applications, you might have an iOS 5 or any other Android or any other different target system configurations. So all these different target system configurations is called the platform. Now different softwares are built to run in different platforms. For example, HP QTP, which is a test automation software, this will not run in any platform other than Windows. This will only run in the Windows target system. So when you're talking about your application, when you want to understand what platform this works in, so they'll give you a certain configuration. So this application will work in Windows 8, 9, or I mean there's no 9, but Windows 7, 9, 8, or they'll give you those specifications. So the platform is all about the target system configuration where your application would run. Which brings us to the last one in our list, which is testing. Now we all know what testing is, correct? But when it comes to software testing context, what I really like about the definition of testing is that this sets the scope of what we have to do as testers. Now help me out here, team. Give me your opinions on what you think is testing. So use the chat window, please. It is finding defects, looking for bugs, auditing, customer satisfaction. It is to test functionality. Okay, all good questions. Now here is my question. Here is my follow-up question on all your opinions. Running software in different conditions. Yes. Now what happens when you find a bug? We report it, we document it, okay? Report to developers, okay. So, do we fix it? Exactly. So, testing is using a software with the intention of finding bugs. So here you are actually using the software, putting the software to use, and our job ends at finding bugs. So we definitely end our job at finding the defects, but we do not fix them. So this is again, we might consider this to be very basic, but again, as I said, in the class we don't take anything for granted. We want to set very clear expectations on what something is and what something isn't. So yes, testing is using a software and finding if there are any discrepancies between requirements and what the software is really doing. Thank you, Amelia. Yes, that's a perfect definition. So, but then our job ends at finding bugs. We never ever under any circumstances fix defects because technically we are not equipped to do so. And when you're looking at it on a responsibility-based situation, it is not our job to fix it. So either ways, testers don't fix bugs. So yeah, those are the words that I had in list. So any questions, or if there's anything that that's basic and you want it defined, just let me know. And once we have addressed all those questions, we'll move to the software development lifecycle. So are you all with me so far, team? Is everything making sense? Great. So let's move to the development lifecycle, but in the meantime, if you have questions, as always, feel free to let me know. Now, as we talked about earlier, software development lifecycle is basically the sequence of steps that every software follows from the time it starts being a problem and till the time it ends becoming the solution. Now, whenever, see again, this is something that, I find useful. So whenever you hear life cycle, so this morning I was reading about HP Agile Manager, and there they were talking about release life cycle and backlog life cycle and all that. So some of the common ways in which you can easily understand the meaning of what the concept is about is, anytime you hear the word life cycle, this is talking about the beginning to end. So if it is talking about a release life cycle, so release is nothing but a particular project. So if we are talking about a release life cycle, when we are discussing the topic release life cycle, we are going to talk about everything that's part of this release, starting with the beginning till the end. So following suit, we have software development life cycle. Sorry. Now, software development lifecycle is talking about the time the software starts as a problem till the time the software ends up, or the end product, which is now the solution, and the intermediary stages that are part of it. Now, usually there are 6 phases in the SDLC, and those are initiate, define, design, build, test, deploy. Now, before we go there, let's talk about how does the initiate even begin, because we are talking about all of these steps in the context of IT. When the project comes into the hands of a software builder, this is where it all begins. But before that, I think it might be useful to set a little bit of context on how does SDLC even begin. So anytime you're trying to understand how IT works, or how projects get built, it is important to understand 3 main stakeholders. So there's a client or the business owner. There is a software builder. These people are called the producers, but then again, doesn't matter. And then there is the end user, or the customer. So let me give you an example. Now, if I have a store, I'm the store owner. Like, let's say I sell cars. Okay, so I'm a dealer. I'm a car dealer, and I want to have like a a website that actually works as a virtual store for me, so which helps me buy and sell cars online. So right now mine is a physical mortar and cement business, but I eventually want to go into a virtual software website based business. Now, being a car owner, do you think I can build it myself? I can't. So I will have to reach out to somebody who can. So that reaching out, I'll do it to the software builders or the software service providers, whoever is in the IT who can build that software. So I will reach out to the software builder. So the builder will eventually build the software for me and give it back to me. But is the product for my consumption alone? No, it is for my end users. So the customers, the people who are buying to, trying to buy this card. So these are the 3 entities that are always a part of a software system. So right now we have the business owner, the software builder, and then there is the end user. Now, before the SDLC even begins, the business owner realizes that he has a problem on hand. That means he needs a software to be built either to function as a product or as a service. So they do have a problem on hand. Now, when you have a certain work to be done, do we just hand it over to the first person you find? So if you have to buy like a laptop, do you just walk into any store and pick up any one of it that you see? We normally don't. We shop around, we look for the best case scenario, we look for what suits our criteria, all of these things, and then we make a choice. So similarly, all the business owners or the clients, they don't approach like any software service provider to get the software built for them. So they actually open this up for multiple providers. So they publish or broadcast this information that, hey, this is what I'm trying to build, this is what I need help building, and these are the few details. So the business owner, being a car owner, in our example, probably will not know how to design the site, what kind of elements to use on it. They probably don't know all that, but they will give you high-level information that the site should be available both on web and on mobile. That means on PC or on laptops and the mobile phones, and they'll also tell you that it should allow the users to buy, sell, and view cars or inquire about cars. So all of these high-level details, like how they conduct the business, they probably will have an idea, and they'll broadcast this information to multiple software providers. So at this point, what the software providers will do is they will pick up this information. So they'll get the details. So individual software service providers, they get this information from the client or the business owner. They get the details of what is needed. They perform a feasibility analysis. Feasibility analysis, will discuss that technical term going on. But at this point of time, feasibility analysis is about whether or not a certain requirement can be met. So if the client says you will have to, incorporate a mechanism where, we should be able to see the client over the webcam, that probably is not something that can be implemented. So any features, so the client might ask for 100 features to be included, but there are some limitations to how many we can include and whether or not something is possible. So that kind of feasibility analysis is performed. Technology decisions are made. So again, technology decisions in the sense what programming language to use, what database to use, all of that. Infrastructure decisions, how many people are to, so all of these decisions are made by each software service provider. Following which, the software service providers, this is not very clear, I know, but I'll just try and maximize this. So each software service provider will prepare what is called a proposal document, and the proposal will have all this information. It will have the solution, it will have schedules, technology details, budget, ETAs, maintenance agreements, so all kinds of agreements, legal contracts, everything will be a part of this proposal document. So right now the client will be in a position where they receive multiple proposals, one of them, and pick out which one is the best option for them, and they sign this. They sign the software service provider. So that is how a client and the software service provider establish a relationship. And once all the legal contracts are signed, proposals are accepted, that is when the initiate, define, design, code, test, deploy. The SDLC begins. Now, how much are we testers going to be involved in the process of bidding and proposals and everything? Probably not so much. This is just to set a reference on where SDLC begins and what are the pre-steps before that. So this is just informatory. So once all those pre-steps happen and the SDLC begins, the very first stage is initiate. So let's create a process document and keep writing what we discuss. So SDLC is a process. Process in the sense it has a few steps, it has few inputs that go into it, and it generates a certain output. So whenever we discuss processes going forward in the class, we'll create a process document, and process documents should have mandatorily the input. That means when to start. And then there's also an output. What is generated, or what is the final outcome of a particular step. And we'll also talk about actors, or who participates, or who contributes, that sort of stuff. So whenever you're trying to learn any process, always ask the question words. What is it? Who performs it? When is it performed? How is it performed? Where is it performed? I mean, you might be wondering how is where relevant, but I'll show you that it is. When, who, why. So you also might want to understand why it's going on. So again, the way we word these might be different. For example, we are talking about input, when to start. So that is, we are answering the when question. What is the output? That means, of course, we'll discuss that later. So in the output and, when we're discussing what, all of these question words are going to get answered. So this is a great way to learn any process. In the future, we'll learn, what test plan is and, what test cases are. So always try to ask these question words in every context. And, there's a lot of information that can be obtained when we do this. So let's get started with what the input is for us to begin the initiate step. Now, initiate step is one of the first steps that happen in the project. See, the client has given you a few, high-level details. So they have told you, hey, I need a site that conforms to so-and-so standards. How about now? Okay, nothing changed from my end, but okay. Well, that's weird. Okay, now that we are back, we can just go on. All right, sorry about that, team. I have no idea what happened, but okay. Let's just go on. So the client or the business owner, they have a few requirements. Now, and then the software service provider has had a proposal document for which they have agreed, like, few high-level information. Like, for example, we'll take 3 months to build this software, we'll charge X amount of money, and we'll need so-and-so infrastructure from your end. So all of these agreements that they have made. Usually the people preparing the proposals or presenting the proposals, accepting them, these are high-level business or pre-sales representatives. Usually these are not the people who will directly work with the project. So that is why in the initiate phase, the client, once are there business analysts at this point? Maybe or may not be. We'll discuss that in a little bit, Tina, but that's a good question. So there is the client, there's the software, the high-level business team. Now, once the proposal is made, the software service provider will, start a team who is going to be in charge of delivering to the client. So the team formation happens. Once the team formation happens, the initiate step begins. So in this team comprises of the project manager, who is the overall in charge of the entire project, and this is, the project manager is not just responsible for dev or QA or any of the other teams. So this is for the entire project. So the project manager will manage the entire project, make sure that it is on time, make sure that the infrastructure is all set, and all of those other things. So the project manager is not team specific. So he is not just a manager for development or QA or something like that. And in this step, why always keep high-level question? I'm not sure I understand that, Patricia. So then there is the, let me know what you mean and I'll try to address that. And then there will be a business analyst. Now, who is a business analyst and what is their role? Now, business analysts are people who are subject matter experts. So in our example, if we are building a car dealership site, our business analyst will be someone who understands the car's business. So the sale and all of that, he understands that, and he also understands how software systems that cater to the car business are built. So business analysts, they come with a unique set of experience that lets them decide how the software that belongs to a certain criteria has to be built. So here you see, this person knows the car business very well, so they can give, they can give the developers and the testers pointers on how they can implement, all their knowledge in the software. So these people actually translate the physical business into the virtual business. Now let me give you an example. Now when you go to a grocery store, so this is the physical, brick and mortar business. So when you go to the grocery store, what do? We browse through the aisles, we pick and choose stuff that we want, we place it into the shopping cart, we go to the checkout counter, we pay, and we are done basically. So these are the steps that we take. So if it is the virtual web-based application like store.com, let's say this is the virtual web-based application. So don't we all do the exact same things even in the virtual business? Now it's basically the business analysts who design these sites, or who come up with a solution. So this online system, we have established that it's a solution. So the problem right now is, in the store.com, you will have to provide a means to browse. You'll have to provide a means to pick stuff, to add it to the shopping cart, to check out, to pay. So all of these aspects have to be formed into a solution form that can be incorporated into your software and told to the developers. Now, grocery store is something that we use every day. But what if it's a much specialized business like healthcare or health insurance? Now, clearly, as regular users, we don't have insights into that kind of business. So, business analysts are subject matter experts, or SMEs. They are simply called SMEs. SMEs stand for subject matter expert. And they have a lot of expertise on the core business area itself. So based on their understanding and based on the client's needs, they develop what is called a business model, and they give that to the developers in order to implement. So it is the business analyst who design the application. I mean, design in the sense, I'm not talking about how the menus have to be placed, not that. So we're actually making a virtual equivalent of a physical business. So how does this business model get formed? It is through the business analyst. So as I was saying earlier, sometimes I get participants who say that I'm a beginner and I want to become a business analyst. Now there is very rarely there is a chance that freshers get hired as business analysts. The reason being, business analysts are expected to be experts, and expertise that comes is something that comes with a certain years of work, or with a certain amount of work that you put in. So that is business analyst. So are you all with me? Does this make sense so far, team? Okay, sounds good. So at this point of time, the project managers and the business analysts, they meet, or they are in touch with the client. So the client, the business analyst, and the project manager, all of them, they sit down and they talk about the application. So we talked about how the client's initial requirements are sent to the management team, and they prepare a proposal and send it out. And coming back to Tina's question, usually the people who give the proposal documents, they are called a pre-sales team. So they are usually, I mean, ideally there should be a business analyst, otherwise there will not be a a clear-cut understanding of what kind of software we are going to build. But usually pre-sales team, they do have a lot of experience in building proposals and all that. So they may or may not have business analysts. So which brings us back to what happens in the initiate phase. So in the initiate phase, usually there's a lot of meetings. The client meets up with the PM and the BAs, and here we are trying to make a list of business requirements. So the intention of this step is to understand the business and gather all the client's needs. What is the problem that they're facing? What kind of solution they are looking at? All of those things. So if the client says, I need to be able to, the customer should be able to buy a car, the customer should be able to sell a car, they should be able to view inventory details, they should be able to talk to a customer care agent and inquire about prices and stuff like that, and if they want to show the daily deals or if there's any sale happening, that sort of stuff. So they'll give all the high level details on how they want their site or the product to look like. So this will be gathering all the client's requirements is the first step in the initiate phase. Now, while the gathering happens, the inbuilt activity that goes on is the feasibility analysis. Now, feasibility analysis at this point answers only one question. Is the requirement that the client is putting forward, can it be built? Yes or no? Now, do you think there are any requirements that cannot be built, team? Absolutely. So let me give you an example. There was one, so actually this is a real example. There was one time the requirement was the site that was going to be built, the product that we are going to build, it should be username and password, restricted. This is fair enough. I mean, who doesn't want, a certain amount of security on the system? So definitely, the users can register this to the site, and they should register with a username and password following the steps, and they can be, recurring visitors to the site. They can come back, use the same user ID, password, and log in. Now, the other requirement that this client had was the password that they are using for this site, it cannot be used or cannot be the same as any of the other accounts the user has. So let's say this is the car.com site, and here I have X and Y as my username and password. So according to this rule, if I have a Gmail account or Yahoo Mail account or a Facebook, LinkedIn, any other account, I cannot use the same password for any of these. Do you think this requirement is feasible? No, because you cannot tell your customer how to set their password. I mean, you can give instructions, you can give guidelines. Most of the time sites do. They tell you, hey, you cannot have, all words. You should use alphanumeric. You should use a certain word length and all that. So that kind of restrictions you can definitely place, but you cannot tell them to not use something that they've already used in. So probably you can tell them, but at this point of time, can you check what their other, account's password is? We can't. So some requirements are not feasible. They cannot be built. So that's the sort of feasibility analysis that goes at this step. Another thing is, let's say you have you do have Microsoft Word. What does Microsoft Word do? It lets you write documents, and it lets you write them easily. That means you can use different fonts, different styles. You can automatically create table of contents. So you can insert a header, you can insert footers. So there's a lot of things that Microsoft Word can do for you when you want to write a document. But if you expect Microsoft Word to read your mind and write the document for you, can it do this? Definitely no. I mean, maybe in the future it can, but right now it cannot. So there are some requirements that are simply not going to be able to translate into a software system, and it is up to the business analysts, project managers to convince the client, let them know, hey, this is not possible, we can do this, but the third thing is something we cannot address. So all that is a part of initiate phase. So if we were to write down what happens here, the business requirements are listed, analyzed and finalized. Now how does this step work? So this step is usually in the form of meetings. And the input to start this is when the proposals are accepted and the agreements are made. And what is the output? The output for this phase is a document called business requirement document. This is also called the BRD document. And this is written, sorry about that team. This is predominantly documented by the business analyst. And also the project manager, there is a secondary outcome to this step, and that is generated by the project manager. The project manager creates a project plan. So the project plan will include information like, exactly what dates we are going to start, which step, and how many team members we are going to have, what are their individual roles and responsibilities, all of that high-level project dates, team members, the effort estimation, all of that is part of your project plan, and the owner of the project plan is the project manager. So the project manager will create a project plan. So we addressed all of these, the majority of it, and going forward if we have anything else we can definitely include it. So this is pretty much what happens in your initiate phase. So you can say that the scope is defined in this step. So to what extent are we building? See, for example, the client might have like 10 requirements, but due to budget reasons or due to time restrictions or whatever it is, the software company only takes on 5 of these requirements, will not build all of them. So it is very important to define the scope and get an agreement on it. So you might say, hey, these are the only 5 we are going to take care of right now. Is that okay with you? So that kind of scope being finalized is something that happens in the initiate phase, and that's one of the most important things that is, to be done and to be out of the way before we move any further. So any questions so far, team? Alright, so the next step is the define step. So the define is where we start to work with the business requirements and move on to making them functional requirements. Now what is functional requirements and what we are going to do? Usually in the software development lifecycle, the model that we are seeing right now is called the waterfall model. The reason why it's called the waterfall model is because the output of a previous stage is the input for the next stage. So the input for the define phase is the BRD document or the completion of the BRD document. So once the BRD document is available, we can say that we are ready to start the define phase. So we'll talk about what the output is, but before that we'll talk about what happens in the define phase. Functional is what will the system should do. Perfect. You're right. Now, I'm talking about the user should be able to buy a car. So this is a business requirement, correct? So the system that eventually is going to get built should be able to let a customer buy a car from the car dealership site that is eventually going to be built. So this is a business requirement. Now, how do we implement this? How can a software enable a customer to buy a car from the from the site that we have? Now to do that, there should be a browse or a search feature to actually choose the car. They should be able to view all the information including the quote and all that stuff, and if there's any car history that you should be able to see, all that should happen. So this is still Still cannot hear me, team? Okay. So Sandhya, it might be, just an issue with you. Try and see for a few more minutes. So there's browsing, searching, this is still, making a choice. I'm still choosing. So once the choice, great. So once the choosing is all done, then I'll move to purchasing, which is making a payment or things like that. Now to do all this, what should my website have? What options or what functions should my website have? There should be a search function. So search might be, enter the make or the model of the car, the price range, the year range, all of these fields. There might be a search button, cancel button, all of that. So to enable the user perform a search, now at the end of the day we are trying to satisfy the buying car business requirement. But to do that, we have to break it down into individual functions or capabilities on your website. So this is one function that will enable the user. So that is a constituent element that will enable the final user to buy a car. So you see, one business requirement can be broken down into multiple functional requirements. Now functions are nothing but the capabilities of the site, what the site can do, what the site cannot do. So search, payment options, looking at a car's history, all of these are functions. Functions are the things that your application can do. So business requirements, they get translated into functional requirements. So when you have a certain business need, how can the site accomplish that? So that is, laid out, or that is drawn up in your define phase. So the actors in this phase, there is still the project manager. Now project manager, starting from the define phase onwards, they play a much more admin sort of a role, which means they do not have a direct participation. They may or may not have a direct participation, but they will overlook the entire process and they monitor it. And then the business analyst plays a crucial role in this step, and the developers are involved. And starting define phase, the client is not involved in the waterfall model, because they'll let us know what needs to be done, and now it is the task of the software service providers to actually make the software happen. So in this phase, the development team gets involved, and what happens in here is the business requirements are broken down or translated or transformed, whichever choice of words that you want to go with. So if you see here, the focus in stage 1 is all about the business, the car dealership business. But starting phase 2, which is the define phase, the focus moves to the software, what the software can do, what the software cannot do. So that is why here all the technical team members are involved, not really the client or any other business entities here. So the focus from now on is the software system, not exactly the business per se. Of course, at the end of the day, you want to satisfy the business requirement, but here it gets much more technical. Now, how does this happen? There is again a lot of meetings here, and this is actually physical work, which means there are a lot of diagrams drawn up, design decisions being made, and functional decisions being made. So this happens in meetings, and also the physical work on the floor. And the output of this step is what we would call, this is also another document, functional requirements document. So all the functional requirements that the software system is supposed to satisfy are documented in the functional requirements document. So this is called the FRD. Now functional specifications or functional requirements document is also called functional specifications document. FSD, or it's also called system requirement specification, SRS. So all of them mean the same. Different teams address them differently, but this is pretty much the same. So this is the output of the define phase. The next phase is the design phase, and clearly following the waterfall rule, the FRD is the input. So the output of the previous stage is the input for the next one. Following that rule, the input for the design phase is the FRD document. And what happens in the design phase is three things actually. One is the physical, the look and feel of the site is designed. That means, see, if you're looking at the go-to training console, it has few options placed in a certain strategic way, right? So how are all of these options placed, in what guides those decisions? All of those things are determined in the design phase. So basically, the physical structuring of the elements or the functions on the site is what goes into the look and feel decisions. The second thing that happens in the design phase is basically the designing the database structure. Now if you see the applications, there is more to what you're seeing on the screen. Say for example, you're accessing your online banking account. So you are trying to look at your account transactions. Now these transactions are originally stored in a secure database, but how are they appearing on your web page? So whenever a transaction or an action is being performed, there is this back and forth interaction that is happening between the web page and the database. So you are sending information into the database and receiving information from it. So this interaction can be very, very smooth and successful only if the data is organized correctly. So if your system, when it is looking for transactions, has to search in your database and the data is not organized correctly, this transaction is going to fall apart. That is why the database structure has to be designed in a way that it enhances easier retrieval and all that. Now this is something, again, may or may not be done by developers themselves. Sometimes when the data is very critical, complex and composite, the database structuring is done by DBAs or database administrators, data architects also. So there might be data architects and then there might be database administrators. So the design, all of these sorry about that. So there's database administrators, data architects and all that. So all of these people are going to be involved now. So the PM again will play a overall monitoring role. There's the business analyst, there's the development team. In addition to these, there is DBAs or data architects, all of these team members. So look and feel decisions are made. And database structure is defined. And the third thing that is done is use cases are defined. Now use cases are nothing but, we know that there is a search feature on the site, correct? Now how can this search be used in how many different formats? So that is something that is defined in the usage. So in the use case, we'll talk about the actors. Now who can search? So the administrators can search, can only the registered users can search, can visitors, that means unregistered users, can they also search? All of these things are decided. And then, how can the search work? First is the search will retrieve results if the criteria is correct, right? And if the criteria is incorrect, or if I have not entered any detail which is incomplete, in that case my search results will not return a result. They will return errors, right? So this kind of detailed use cases on what a certain feature or function will do is also derived. Now use cases document can be kept separate or it can be part of FSD document. So in the design phase you'll go back and add them to the FSD, but use cases are also defined in the design phase. The output of the design phase is the technical design document. So TDD will contain, now use cases are defined, but these are incorporated into your FSD. So they are not incorporated into your TDD, but in addition to both of these, a technical design document will include details like this. For example, I have to incorporate a search feature. What algorithm am I going to use? Now what Java class do I use? So all the technical implementation related details to be consumed by developers while they are building the system are also made part of your technical design document. Now this is also in the form of meetings and work, lot of work actually. This also is a very important step. Now there are some questions, let me take that. Can you tell more about the database? Actually database is a huge topic in itself, so if you have a specific question about database I can take it. Otherwise, especially for day one, it might become a topic that is slightly overwhelming if there are any beginners. So if there's a specific question, specific topic, let me know and I'll take it. Deepti's question is, so the tester will know each and everything from initiate process. That's a good question. So far we haven't talked about what the involvement of testers is, and we are going to do that, so just keep an eye out for that, and we'll get to that in a bit. So can you tell about use case? So use cases are basically defining how a particular functionality will work on your application. Again, this is slightly premature to look at use cases, but I will, we will have a document on use cases, and we'll actually try and work with it going forward. So use case is just defining how a particular functionality will work. Now, if I just tell you that there is a search feature, the only thing that we think about search, especially as a user, is you'll just think that a search feature will just search based on the input that we provide to it. But even though this is the primary action, there are other things. So if I don't provide a correct input, it should give me an error. If the data does not exist in the database, it should behave in a different way. So all of these are different ways in which the search can be used. So all of those different scenarios or situations are documented in your use cases. As I said, just give it a few more minutes, or if I don't think we're going to do that today, but sometime next week definitely I'll show you use cases, and that will make more sense. Define functional requirement. Functional requirement is nothing but the capability of your application. For example, right now we have go-to training. What are the functionality? What is the functional requirements that this site will, the go-to training software has? It lets us schedule meeting. It lets us meet in a meeting. It lets me share my screen. It lets me communicate with you all through the chat. So all of these are capabilities, or things that this site can accomplish. And how is it able to do that? By all the options that it has. And those options are nothing but functional requirements or functionality of the site. Right? So let me know if that makes sense, or if you have further questions, and we can take it. And in the coding phase, the next phase is the code phase. Now for the code phase, the input is BRD, the FRD, and the TDD. All the documents that have been created so far are all the inputs. And what happens in this phase? The code is created, or this theoretical solution that is proposed in all your previous reference documents is implemented. The developer actually sits down at a machine, starts coding, start writing the code. So this is where the software starts to take form. Now who will write the SRS and FRD? This is a collective effort by the development and the BA. Both of them write it together. So coming to the coding, this is a step that is predominantly owned by the developers, and there might be other teams like DBA teams and data architects who play a supporting role. And then there is the business analyst who overlooks the entire process, making sure that the software being built is in line with the business requirements. So finally, it has to satisfy the business needs. So BA will also overlook, not a major role, just a slight overlooking role. Surabhi, your hand is raised. Did you have a question? Does tester need to do coding work as well? No, but we'll talk about that in a little bit. So was that all? Okay. So these development team is, plays a major role, and here the coding is all done, and the software, the output of the coding phase is the software ready to be tested. And this is all, again, physical work, that is the actual programming and all of that goes into this step. There is always meetings in an IT framework, but the meetings are considerably low once the actual work begins. Now the next step is test. Finally, right? So test is where the software gets tested, because in the previous step the software is ready to be tested. So we have the input is the software that is ready to be tested. Here the QAs play a major role, the QA team, quality assurance team, or the software testing team. Now if anybody is wondering why I keep referring to the software testing team as the QA team, we'll discuss that tomorrow, because that's a part of one of the main important topics that we do have on schedule. So the test phase is where the software testing team gets involved, or the QA team gets involved, and we test the software. At this phase, what do we have? The output of this phase is the software that is tested and ready to go live. And then what happens here is, obviously the software gets tested, and this also happens a lot of real work. How does this happen? It can happen either through testing, which is manual, or you could use automation tools and perform testing. Both of them are okay. And then the final step is deploy. I know that we are not discussing the tester's job to a greater extent. There's a reason for that. We'll come to that in a little bit. In the deploy phase, the input is the software that is ready to go live, and the output is that the software is live. So once the software is live, the deployment is done, and the team that is responsible to do this is either called the operations or the support team. So these people are responsible for deployment. So deployment is nothing but, again, this is part of the jargon. Deployment is a word that is used anytime you install the software into the live environment. So again, environment is also a word we did not discuss. We'll come to that in a little bit. So when you get these CDs of software and you install it on your machine. So what you're doing in effect is you're deploying that software onto your laptop. So deployment, even though it sounds complicated, it's just installation of the software into the live environment. Again, what is environment? We'll discuss that in a little bit. So what happens here? The software is sent live, and how? Again, there are code deployment tools and all that, but we don't need to go there. So this is the beginning to end process. In the initiate, the scope is defined. In the define phase, the business requirements are transformed or broken down or taken further as functional requirements. The functional requirements are again elaborated technically. The design decisions are made in the design phase, and then the code is created in the code phase. The software is tested in the test phase. Once all the preliminary stages are done, the code is sent to the live environment, which means it is deployed. That is what happens in the deploy phase. So this is once the project is deployed and the software is live, it is available for its end users or customers to consume or put to use in any way they see fit. So this is the software development lifecycle from the beginning to the end. Any questions, team? Are you all with me so far? Great. Now, so this is waterfall. How different is it from the agile model? That's hard to answer in a single sentence. But if you could just hold it for 2 more days, we will deal with agile on Wednesday. But the reason why we are discussing waterfall model is because no matter which model of development that people are going to follow, at the end of the day, the software more or less follows the same sequence of steps. So let me give you an example. Can we start writing the functional requirements if we don't know the business requirements? So we always start with business requirement. We move on to functional requirement, and based on that we make technical decisions. Based on that we start building the code, and then we test it, and then we send it live. So this sequence of project development, it does not change no matter what methodology that we are using. But then there is a lot of claims, and there's a lot of discussion in the market saying how waterfall model is different from agile model and all that. But waterfall model is really the core fundamental concept, and slight modifications, implementation changes are made from one model to the other, but at the core it's all the same. So that is why I find it very important for us to understand the waterfall model first, and when we move to agile, I'll show you how in agile also there is inbuilt reference to waterfall, except that it is slightly implemented differently. So we'll definitely deal with that, but probably now is not the time. And then Tina's question is, FRD, FRS, SRS are all the same. Yes, they're all the same. They are just referred differently in different teams. That's all. Okay, so this is the end-to-end situations. Now, do you think our role is just like, one part of being QAs? So do you think we only come in stage 5 of testing team and we have no other involvement from the beginning? I mean, think about it. If we were just to come in stage 5, how would that be? Now, I am a happy tester, not really involved with anything that's happening. So, totally isolated, not really in process, involved in the process. So, there is the initiate step that is done, define is done, design is done, coding has begun, and this is where I'm told to come in here. So I've been isolated so far, and right now I've been given an application and I am told to test. What do you think is wrong with this situation? Now let me simplify that. Do you think this is optimum? Do you think that if I'm told to test something that I have no idea, no clue about, do you think I'll be able to test effectively? No. Why is that so? Now when you want to test something, say you should know exactly. So if you take like somebody who does not know how to drive for a driving test, do you think the test would be successful? Definitely not, because that person has to know at least a little bit about how to use, the steering wheel, how to brake, how to, probably test the stereo system, have some sense of, where things go and all of that. So when a certain person who is not knowledgeable about the core concept or the core application of the product and the way it should work, so if that person is not knowledgeable about all that, the testing also is not going to be effective. So that is why it is not a good practice to just bring testers at the end. Now chances are we will still be able to test, we will still be able to push some buttons. Now if I tell you go and test me walmart.com, we probably will be able to test it. We probably will be able to push some buttons, infer things, and based on our previous IT or previous experience of using different software systems, we probably will still be able to test to a certain extent, but that is neither here nor there. Now testers don't just come at the end and push some buttons and give a yes or no answer. We basically do more than that. We are the quality assurance representatives for a project, which means that we not only find defects, we assure the quality of the product. That means we tell them what possible areas this application falls short. Now, if the tester just gets involved in the test phase, that kind of productive output is something that the tester will fail to provide. Now, to remedy that situation, the best practice is to involve the testers as early on in the process as possible. So, ideally, the testers should get involved in the initiate phase of the project itself. But having worked in a lot of projects, having worked in a lot of teams, I've seen it both ways. Sometimes the testers do get involved in the initiate phase, sometimes they don't. But I don't see that testers have a lot of value to add in the initiate phase. So usually the involvement of the QA team in the initiate phase is optional, or I would say it is minimal. A lot of times the QA team is not involved in the initiate phase. So even if they are, there's really not a lot of value add that we can provide here. So usually in the initiate phase there is no involvement. We'll also talk about what QA team members are involved at which stage. So once the once the project moves to the define phase, right now the work is being done on the functional specification document. So while the define phase is in progress, do you think we have the FSD document? We don't, because that's still being built. So right now what we have is the business requirements and the project plan. So the project plan is also created in the previous step. So we have the project plan and the business requirements. So here usually in the beginning stages only the QA lead is involved. So here it will just be a one person, and the QA activity that is performed at this stage is analyzing the scope, and based on the scope we prepare a test plan for ourselves. So test planning is one of the first phases that begins, and it is something that is led by the QA team member. So here test plan is initiated. And in the next stage, when the project moves to the define phase, you will have an FRD to work with. So at this point of time, the QA team will perform the FRD review and come up with understanding functional requirements. So we'll make a list of all the functional requirements that we are going to test, and we'll also figure out, we'll also try and figure out what to test in these functional requirements. So we will identify what to test and figure out, we'll identify the requirements and we'll figure out what to test in them. So at this point of time, we'll prepare something called the test scenarios. So we'll talk more about that technically, what test scenarios are. But say for example, you are given a Gmail application. So you'll figure out what are the features. Like it lets you send the team, like it lets you it lets you send an email, it lets you send attachment, it lets you receive emails, all of that, correct? So these are the features. Now what would you test in there? What kind of attachments is it allowing you to send? So in detail you are going to make a list of each and everything that you will test in each of these features. Now here the entire QA team is involved. So usually FRD documents are can range anywhere from few tens of documents, few tens of pages to few thousands of pages. I once worked for a railway client and their FRD was 1,080 pages. I remember that exact number because it was a huge document, and to really scroll in Word it used to take a few minutes. It used to freeze for a few minutes. It was that big and cumbersome. So FRD documents can be pretty huge. So the entire QA team is involved at this point. So they review, identify functional requirements, and they kind of like break it down, identify what to test, all of that. And the QA activity here is again the same thing, and you will come up with test scenarios. And as Patricia pointed out, once we identify the test scenarios, we know the testing scope. So what are we going to test and to what extent? We know the testing scope, which means we'll be in a position to better plan how much time it will take to document and how much time it will take to actually test. So all of this information you will incorporate into your test plan. So at this point also the test plan gets updated and the test scenarios are written. So that is the QA activity that goes on in this stage. And the third stage is where the coding is happening. So in the coding phase, the QA team, again the entire team is involved, will perform test documentation, test data gathering. So to test a particular application, you need to write what we call the test cases. So so what are test cases, how do we write them, all that we'll see later. But QA team will write test documentation, and this will give guidelines on how to test. So we will write test cases which will give guidelines on how to test. We'll gather the data that is required and all that, and that is when we get ready to test. And the next thing that happens is the testing phase itself. And here we have the application under test, AUT. We perform system testing, which brings us to the next question. What is system testing and what other forms of testing exist? So we'll take that in a little bit. Now here what we do is we test the user from the perspective, we test the application from the perspective of the end user. And to do so, we use the test cases created so far in the earlier steps. And this is where we identify defects and let the developers know and all that. So we do all that activity. So again, the entire team is involved. Now once done, we provide a QA sign-off, which will pretty much certify that the product is ready to be used. So sign-off is nothing but a kind of approval that we provide, saying that, hey, we tested the software, we find it fit to use, so go ahead and you can go ahead and deploy it. So once that's done, the QA team's involvement is done. So this is how the QA team is interspersed with the rest of the SDLC activities. Now, test scenarios are to identify what to test, and test cases how to test it. Yes, that's perfect, Emilio. Now, since this is, this is how the QA team is involved, and these are the activities that QA team will do in parallel, the next thing that we could discuss at this point is the different stages of testing. Now, the different stages of testing are unit testing, integration testing, system testing, and UAT testing. Now, unit testing is, see, in IT teams, work is done, as a team, not as an individual. So usually developers, they collaborate. So each one will probably break it down into a certain module. Hey, I'll work on module A, you work on module B. So some sort of that kind of work distribution mechanism takes place, and each developer, once they have a unit of code, a certain piece of code that can work as an autonomous unit and that can function. So we will discuss more in detail on what unit testing is, integration testing is tomorrow. But when you have a certain piece of code that will accept a certain input and produce a certain output, this is generally called a unit of code. So when individual units of code are developed, the developer will test their individual units of code, and if there are any problems, they'll fix it. Now, the reason why developers perform unit testing is because, what if I find let's say there are like 10 lines of code, and I found an error in line 2 or 3. Now, how will I fix this? Can I fix it? Will somebody else fix it? Or, can the QA team fix it? Now, if the QA team is going through these lines of code, do you think I will be able to fix it? No. So, since it is something that, developers do at the point where, the software is still premature and, it's still under construction, it is recommended that the development team do this, and the development team, if they find any errors, they'll fix it themselves. So unit testing is the most basic level of testing, and it is performed by developers when an individual piece of code that accepts a certain input, produces a certain output, is ready. Now, once a few units of code are ready, all these units are put together. So if there's unit A, unit B, all of them are, unit tested individually. They are put together. And this kind of testing is called the integration testing. Now, once all the units are put together, then it will be final product, correct? So once the final product is ready, that is when the QA team will test it. And since this final product, it looks pretty much like, something that the system would look like to the end user, this type of testing is called system testing. And following system testing, there is UAT. UAT testing is performed by the client. See, when you, say you have asked your mechanic to fix your car. Now you're not going to just get the car back and come home. You're going to test drive it, see if the problem is fixed or not. Similarly, when the client has given you the job of making a software product for you, they're not going to just accept the delivery without testing it first. So the client will put the product to test also and then take it. And that is called the UAT, or the user acceptance testing. So usually the test phase that you're seeing here, this involves both users and clients, and if the client is involved, that is UAT, or the user acceptance testing, and when testing is performed by the testing team, that's called the system testing. So in the coding phase, you will also have unit and integration testing incorporated. So yes, so first the individual modules are tested, Patricia, and then they are integrated or combined together, and the integration testing is done. Unit and integration testing are performed by developers. System testing is performed by QA teams like us, and then UAT testing is performed by the client, which is the end user. Now another thing that is important to understand is, we talked about where earlier. Where does this form of testing happen, or where does any of this happen? So that's something that we kind of did not discuss so far. So let's talk about that in a little bit. Now Deepti's question is, does the client side also write the test cases? That's a good question. Testing is always performed based on test cases. Now, do you think the client can write test cases? Do you think they are technically equipped to do that? They are not. So that is why they will tell you the aspects of the application that they are interested in testing, and the QA team will provide the test cases for them, which they will execute. So they don't write test cases, but they still use test cases to test. In any case, UAT is a separate topic that we will discuss in much greater detail. But the answer to your question is no, they don't write it, but they use it. The QA team writes it for them and gives it to them. Yes. So the concept of where. Now we talked about platform, that there are certain technological requirements for an application to run. So let's say you need an IDE like Eclipse or something for Java code to run, and you need a database in the backend, an Oracle database or something like that, and an Apache for all the services that go back and forth. Let's say this is the configuration of your system. Now if the development team has their code here, database here, and the testing team is testing it, while the development team is making changes to it. So do you think we will have consistent results if testing is happening in this kind of an environment? So I'm testing something while somebody else is changing it. The results are definitely not going to be consistent in that case. That is why usually the physical, the requirements, if the physical, the physical entities that are important are separated out for development, QA, and production. Production is for when the application goes live. So the exact replica or the technical, details is created, one for development, one for QA, and one for going live. So first the development team will create the code in their own environment, and they will perform unit and integration testing in their own environment. So once they are done with unit and integration testing, and once they are satisfied with the code is then put into the QA team's environment. And here the QA team tests. And once the testing is all done and we figure out it's all fine, then the application moves to production environment. So the environment is nothing but the hardware and the technological requirements that are required for a software to run. That is replicated, or different instances of it is created to make sure that everybody has an isolated situation to work with, and the results, I mean, it's just a mechanism to make sure that we don't get into each other's way, the developers and the QAs and the end users. Now most companies have at least 3 of these environments, but they might have more depending on the size of the project. So at least 3 are mandatory. Now where does system testing, where does unit testing and all of that happen? They all happen in the development environment. The system testing happens in the QA environment, and the UAT can happen either in the QA environment or in the production environment. So the users might decide to actually first send the application live and then test it, or they might want to test it while the software is still in the QA environment. So if the UAT is happening when the application is still in the QA environment, that's called alpha testing. And if the UAT is happening when the application is in the production environment, that's called beta testing. Now we'll discuss more on this later. But for now this is just enough to understand. Tina's question is, does changes which the developers make get saved or affect the code in real time? If there is this sort of an environment separation, it does not. But if there is no environment separation, then it definitely does. See, this is similar to when you want to use your cable system at home and somebody is, the technician is making changes to it. So sometimes it might work, it might not work, right? There might be those static that comes up because the connection has been disconnected because that guy is working on it. So the same thing will happen if the development and the QA, they work on the same system at the same time. So that is why environments are separated. So are you all with me, team, so far? So the last thing we'll talk about is what is white box testing and what is black box testing. Again, we are going to discuss all of these different testing phases and techniques in a greater detail tomorrow. But this is a high level information that I thought we will introduce ourselves to and then conclude the session for today. Now white box testing is any kind of testing that will involve you in the code. Now here the box that we are referring to is the software system itself. Now when I am performing unit or integration testing, do I have to look at the individual lines of code? Yes or no? Yes. But when I am performing the system or the UAT testing, do I have to look at the lines of code or just work on it like the end user will work? So am I interested in functionality or the code? Just the functionality, not the code. So for us, all of this software system is just a black box. We are only interested in providing an input and checking what output this is generating. Other than that, we have no interest whatsoever on how this code is written, what kind of best practices are followed, none of that. So the kind of testing where you don't look into the code, you just treat all the code as a black box, that is called the black box testing techniques. So system testing and UAT are black box in nature. Unit testing and integration testing are white box in nature. Integration testing is also called gray box testing. Why and why is that name justified? Is that name really necessary? We'll see all that tomorrow. Now a quick recap on what we've seen. This is exactly the reason why I really like SDLC to be the first day's topic, because it introduces us to all the different team members. So right now we know that in a software development environment or in a software service or in a software IT related software project situation, you have the project managers, you have the clients, we have the business analysts, developers, QA team. The QA team will have their own QA lead and the team members. Same thing applies to the development. Business analyst, however, is just one person. And then there is the operations team or the environment or support team, who will take care and maintain the environments. And then there is DBAs, database architects, and then there is data architects. So these are all the people that can be involved in your IT project. So this not just introduces you to testing, it introduces us to all of these people and their different roles and responsibilities. It also introduces us to the concept that there are three environments: dev, QA, and production. And it introduces us to, what the QA team's roles and responsibilities are, of course, at a high level. Going forward, we're going to discuss more. It also lets us know that there are 4 levels of testing: unit, integration, system, and UAT. And UAT, there's alpha and beta. So it also lets us know that the first 2 testing types are white box and the rest of them are black box. So pretty much, a high-level overview of what happens in an IT project in a very concise and easy to understand fashion. So that's the SDLC for now, and this is the waterfall model. Clearly, this model has its own shortfalls, and that is the reason why, newer and more different approaches and different kinds of models are coming up in the industry. But as I said in the beginning, everything, is derivative of the core waterfall model, the way it works and its core concepts. So we'll go into the shortfalls, we'll talk about the disadvantages, we'll talk about how the other models try to solve the disadvantages that this model has tomorrow, but that's all we'll discuss about SDLC today. If there are any questions, just feel free to let me know. And basically, just let me know if this concept, makes sense, and all of those things. And I will, in the meantime, I will let you know what the assignment is, and I'll take all your questions after that. Now, the assignment for today is for you to pick a favorite software. So you could, let me actually add a sheet here and write the sample assignment, so that I can send this to you all and you'll be able to just refer to it and get working with it quickly. So pick any software system. So this can be google.com or gmail.com or anything else that you like, or this can be Excel, Word, any software system. Any software will do. And in that, I would like you all to list out at least, if you can do more, that's great, but at least 10 features of it. Now, at this point of time, I don't want to call it functionality, functional elements, functional points, any of those technical things. Just identify the features. So I'm going to pick Excel, Microsoft Excel, and here I'm going to write its features. Now, the very first feature is that it lets us create spreadsheets that are automatically formatted in the row, column, or table format. And what can I do more about this? In a cell, I can change, or it lets us change the format. So try and be as informal as you would like. There is really no format restrictions or any wording restrictions or anything. In a cell, I can change the format of the text. The third thing I can do is I can save the file and send it as an attachment through various mediums. I can copy the contents of a cell and paste it. It also lets me resize the cell length and all that. So you get the picture, right? So just pick a software of your choice, write what it can do, cannot do, and cannot do, of course, does not make sense, but think about all of its features and list at least 10 of them and send it to me at sthcourses gmail.com. Any other email ID, they are not monitored. So please use sthcourses@gmail.com and try to send this at least an hour before the class begins tomorrow if you choose to do it in parallel with the class. As I said earlier, I don't like to impose restrictions on when I want to get this assignment, because we're all professional here. We're all professionals here, and everybody learns at their own pace, and we all have, other commitments definitely. So try and find a schedule that works for you. If you want to do all of them at a stretch over the weekend, that's fine. Whenever you have it, just send it to me. But if you're going to do it in parallel with the class, try to send it to me at least an hour before the class begins tomorrow, so that I'll have enough time to go over all of them. So that's the assignment. The video of this class, as I said in the beginning of the session, it will take at least 2 to 4 hours for me to be able to send that video out to you, because GoToTraining takes some time to finalize it. It applies some codec, and then I'll be able to upload that the video file. All of this takes a really lot of time. So within 4 hours or so, you will get an email from me, and that will have the link to the session. So any questions, team? Anything that you want to talk about in about what we've seen in the class today? So I'll also send this document out. I'll send the training plan. I'll also send these pre-SDLC steps. As I said, we're not going to be involved, but just for an FYI basis, you all can take a look at it and come back if you have any questions. So I hope you all, had fun in the class today. Let me know if there's anything in the format or the style of the class that you would like to see changed. So usually, no, because it kind of defeats the whole purpose of having a short online class. We are not going to go in brief about what we did in the class today. However, the topics are all interlinked in a way that one flows into the other. So that way we will inbuilt talk about the topic that we discussed the previous day, but there will not be any recap session, because that really, as I said, it defeats the purpose of a short session. But you're free to watch the video one more time before you get in the class tomorrow. So that's something you can do. Sure. Course PDF. Vijay actually will send out all the bonus material, if that's what you're looking at. So next time, Tina, if you feel like you've missed out on something, feel free to stop me then. That way I can address your question, or if you just want to repeat me, if you just want me to repeat something, we can do that. In white box testing, do we have to know the code? So first of all, we never do white box testing as testers. So when we don't do white box testing, we don't need to know the code. So no. But if you are going to do white box testing as a developer, then yes, definitely. Thank you, Patricia. I'm glad you liked the class. Okay, team, so if there's nothing else, we'll just sign off for the day. And tomorrow we'll meet up with another development lifecycle model, which is the V model. Syed, your hand is raised. Would you like me to unmute you?